and with a 50 focal length, and pixel size is the individual pixel size. Let's say my camera is Nikon 500, which has a pixel size of 4.2. Okay, and for this declination we are supposed to uh, uh, type the angle of the object we are shooting. Let's say I'm shooting the Milky Way at around 30 degrees declination. I will enter that, and for the accuracy it should be pinpoint. Yeah, right. So based on these calculations, I will get a value called NPF value. With by using this 2.5 seconds, we'll get pinpoint and accurate stars. And as these are rules can be are meant to be broken. You can do a trial and error method and determine the perfect shutter speed for your image. Okay. Uh, do you guys have any doubt? Uh, Hello, am I audible? Okay. Okay, I'll explain declination. Basically, we have two types of how we are having latitude and longitude for our regular calculations of the uh, yeah, and we have something called right ascension and declination in our astronomical calculations, which determine which says the position of the object in the night sky. Like saying if you take an axis x-axis and y-axis, and if you point 0 comma 2 in the graph, it's similar to that in an astronomical way. That's it. Declination is the height, and RA is opposite to that. Yeah. Okay. Can I continue? Yeah, yeah. I will continue. Okay, now let's discuss about the another important factor. Everything in an image is controlled by these three factors: the shutter speed, ISO, and aperture, which we call as an exposure triangle. Okay, and to discuss about aperture and shutter speed are the two physical ways of inputting the light into the sensor. And while we discuss about the ISO, which is an artificial form of inducing the light, we'll discuss it later. And to discuss about aperture is the opening of light which reaches a camera sensor. If you see here in the bottom left of the images, you can see different aperture values. You can see the different opening. The more the wide the opening, you will get the more light in. And if it is too small, the obviously the light entering into the camera sensor will be very low. And here's the reason why I told to use the prime lens. So if you use lowest f number on your lens, you will be gathering too much light. Like see on the image on the right side, difference between the image f 1.8. See how bright is the image, and f 5.6. The image is f 6.3 image is very dark. This shows that aperture gives a lot more light. But the issue with budget lenses is that if you use the lens wide open, by wide open I mean if the lens is 50 1.8, which has an aperture of 1.8, you can't use it directly at 1.8 aperture, because it has many issues like chromatic aberration, coma, and vigneting, etc. To fix that, you can easily fix it. Just reduce it one stop. We discuss aperture in stop values like f stop, like 1.8, 2.8, 3.2 will go on the list. You can just reduce one stop of light and fix all the issues. And the lens which I showed at the beginning, the Samyang 135, which performs extraordinarily, which is made for astrophotography, will perform very well even at the aperture of f2, which is the highest that lens can offer. Yeah. And to see the image star, not how the star supposed to be look. So you can see the shape changing. This occurs mostly in the corners of the images, so not an issue even if you use wide open aperture. Make sure that you keep your target of interest in the center of the frame. And discussing about chromatic aberrations, in the name itself, we can say that chromatic aberrations is spreading of light, reflecting of light. So if you see closely in this top part of the image, you can see violet color fringes, which makes the image ugly, and this is called the chromatic aberrations. You can fix this by stopping on the lens very easily. Okay, we are getting into main main aspect of imaging, and ISO is a key factor which determines the noise. In the next slide, we are going to discuss about the signal to noise ratio, which will determine the how good your image will be and how bad it will be. Okay, this is one of the main component of exposure triangle. ISO is the artificial amplification of the signal. Can I will stop here and explain about signal. Basically, signal is the photons hitting our camera sensor. That's it, the signal. So we are artificially increasing the signal, which results in a noisier image, but we get a brighter image. Here is the there are here it is very much camera dependent. If your camera is an ISO variant and ISO invariant, that's a huge difference. Let me explain ISO variant cameras. Basically, ISO variant cameras is that you will see the same noise increasing if you keep on increasing the noise. Like in the case of ISO invariant, it doesn't matter if you use a 100 ISO or a 12,800. It's the noise produced is same, but the brightness difference will be shown. Yeah, and ISO 800 to 6400 is a sweet spot for many cameras. And this is just a guideline. Even you can use like 12,800 higher, depending on your camera model. Yeah. Okay. Now okay, we'll discuss about. Okay. I have finished about the main exposure triangle. If you have any doubt, kindly let me know. We are getting into the main another important topic of the session. Please drop your comments. Am I audible? Yeah, please tell your doubt. Okay, can I continue? Cool, cool. I'll continue.
Excuse me, Zach. Just turn on your mic.
Yeah, I'm not sorry.
Yeah.
Okay, let's start again. Okay, we'll discuss about signal to noise ratio. And am I audible now?
Yeah, now
Yes, you
it's
are
fine.
audible, sir.
Yeah.
Yeah. Basically, signal to noise ratio or SNR measures the ratio of our signal, which is the light from our celestial object to the background noise present in the image. Usually, this noise is present in the darker part of the image than in the brighter part of the image because these are the unwanted signals that get transformed during the A to D conversion, which is the analog to digital conversion. Basically, when light hits camera sensor, the electrons will convert the image into a digital image. Okay, here we have a small formula. Signal is equals to root square of root of noise. Basically, if our value of our signal is around 100, the noise value is 10. Like even if you increase the signal, the noise will increase. But if you keep on increasing the signal, at some point the noise will be increasing, but not too much. Okay, and this signal to noise ratio can be increased by the following methods. Okay, we'll first discuss few types of noises. So this is the noise which I discussed right now. The photon noise or short noise, which is the which happens due to the statistical nature of photon arrival, and there's something called quantum efficiency, like the amount of light hitting our camera sensor. Everything coming from the night sky doesn't hit our camera sensor. We don't have perfect camera sensor which can capture it all and convert it to a digital image. So there will be some random change in our signal, and signal will be actually signal won't change that much, but the noise will be in different patterns. Like doing of throwing of a dice, you'll get different values. But if you take an average at the end, which is basically image tracking we are using, which is also a statistical thing called law of large numbers. If you do throw a dice many times, at the end we will get something average. That is what we are doing in image tracking. And dark current noise, and this is also called thermal noise, which occurs during longer exposures. Why? Because during longer exposures, where the camera is sensor is open for a long time, the mission is working. So obviously, during warmer temperatures, you'll get more noise like hot pixels, and it will be very annoying to see in the final images. And next, read noise, like the image is created on our sensor, and while transferring it to our SD card or memory card, if a different type of pattern is found, a fixed pattern is found in many images. Due to the transfer won't be that perfect in our camera sensors. There are few cameras like CCDs which can do that, but not the regular DSLR and mirrorless can do that. And this fixed pattern noise is similar to the read noise, but it appears due to the non-uniformities in the sensors sensitivity. We can't avoid this without doing some process, which we'll be discussing in something called the calibration frames in the upcoming slides. Yeah, here are two methods to increase the signal to noise ratio. The goal is the longer integration. How much the longer the integration is. By integration, I mean is the exposure length. Let's say 1 hour, 2 hour, 3 hours. The longer the exposure length is, the clear your image will be. You will be getting good output in the final end. You can do a half an hour exposure, 10 minutes, and in Untrack, the most a guy one can do is around 1 hour, because it takes a lot of effort. You need to be shooting shorter exposures for many shots, like 1,000 shots, 2,000 shots, which can vary your camera sensor, and you need to be replacing the shutter count very quickly. That's some caveat like that, and longer exposures is a way to increase our signal. The longer you expose, the more signal you collect, basically. But because we are doing untracked astrophotography, we can't do longer exposures like 1 minute, 2 minutes in a single shot. That's the issue because of our lens rotation. So finding the optimal exposure is the key. And another way of increasing the signal to noise ratio is image tracking. This is the best part of this hobby, and it will take a little while if you have a slow computer like mine. And basically, we'll see the process of image tracking in the coming slides. Okay, we'll go from here. Uh, Up to now, I have discussed about different types of noises, aperture, shutter speed, I guess you might have some doubt in the discussion of ISO and different types of noises. If you have any, please let me know. It will be better for me to stop and discuss it. Kindly respond anything.
Hello, you explained about the types of noise, right?
Yeah,
So, I heard of running noise.
yeah.
Which type of noise is it and why it occurs is my question.
Running noise is something which is easily avoided in our untracked astrophotography because it occurs with a fixed pattern of our sky. Let's say if I'm shooting the sky exactly without like a perfect tracking sky, if I track for a few hours, the image there won't be any shift in the image, which will causes this running noise and walking noise. Since we are doing untracked astrophotography, we are not gonna track the sky. There will be shift in our images, which will easily it is similar to deterring, like moving the camera sensor a little while shooting, which will easily fixes walking or running noise. Yeah.
Yeah, I got it. Thank you, sir.
Can I continue? Okay, now we are starting about the types of light frames. We are from starting itself we are discussing how to shoot, but here we are talking about the types of frames which are involved in this genre. Basically, light frames are nothing but the individual exposures of the target we are shooting in the night sky. That's it, nothing special. And here comes the calibration frames, which helps a lot in increasing the signal to noise ratio in a minimal way. It is not the only way to do that, but it helps a lot. Okay, starting with dark frames. Basically, dark frames reduces the thermal noise. How? Like we are going to subtract the hot pixels and thermal noise by taking an image by covering our lens cover. Our main image, the lights will have this hot pixels. While subtracting it from a darker image, it will get rid of these dark frames. And this bias and flats will work in the same way. We are subtracting something from the light frames. That's it. That's why we are increasing our signal to noise ratio. Am I making sense? Okay. Okay, I'll tell about somebody else. ISO invariant and variant. Basically, nothing like that. There are two types of sensors: ISO variant and invariant. In ISO variant sensors, let's say if I'm shooting at 100 ISO, there will be a certain amount of noise. Let's say I have a noise value of 10. If I increase the ISO, let's say to 5000, there will be a huge increase of noise, like 5000. I told, right, for 100 ISO, if the value is like 100, for 5000 ISO, the value will be around 5000, just a random number. But in the case of ISO invariant, despite of your ISO, like ISO 100 will have the same noise value, and ISO 10,000, 12,000 will have the same noise value. Yeah, just the change in exposure will be occurred. There will be no change in the noise value. To explain it simply, yeah. Is it fine? Okay, I'll continue from here. Okay. Uh, I just finished about dark frames. We'll discuss about bias frames. Basically, bias frames are captured with a shorter exposure length of a camera. Some cameras offers 1 by 4000 second of a shutter speed and 1 by 8000 second of a shutter speed, which will easily fix the fixed pattern noise, which we discussed while discussing of the different types of noises, and flat frames. And this helps a lot if you are having a lens with dust modes and then high amount of vignetting. Okay, basically how you can shoot a flat frame is that point your camera to the zenith, where zenith is the highest point in the night sky. Place a white screen on that, or something like a white sky, sorry, blue sky, which is something plain, or you can use a wall and get a white image which is evenly illuminated, so that you can subtract everything in the calibration frame is basically a subtraction of from our light frame. I'll show it as a demo in our tomorrow's session. Okay. Okay, I will discuss how image stacking works actually. It's one of the most important thing in astrophotography, despite you are tracking or you are not tracking. It improves the signals to noise ratio in a huge amount. If you can see this GIF image, it shows a single exposure is too noisy, but while if you stack a 35-minute exposure shots, which is like 5 shots, you can see how much difference it makes. It evens out the noise and will get a very good image output. Yeah, and this is the process in which we can do stacking. Like we need to capture multiple images, like including the same object in the sky, making sure it is in the center like every interval. If you start taking like shoot 30 shots depending on the focal length. If you are shooting at higher magnification, the sky will move too much, so that you need to reframe very quickly. Got it? And next, in what happens in alignment. So once you shoot your sky images, while you import into softwares like serial deep sky stacker, what will happen is it will see stars in your frame and try to align them to each other, which will help easily in the process of stacking. So yeah, stacking the value pixel by pixel, it takes the averages, and it will remove all the noise from your images depending on your exposure length, and will get a fine good output. And obviously, every point is similar to one another. Okay, we have discussed this already. Okay. And these are the softwares we use for stacking and pre-processing. Starting from PixInsight, which is a paid software, and this is a master software for astrophotograaphy, which all the professionals use, and it is paid. And we have few free options like Serial, Leaf Sky Stacker, GIMP. And the purpose of Serial is it can do everything like stacking, pre-processing, and post-processing. We're gonna process an image, a data set of mine tomorrow, so that you can see the magic of post processing. I mean, today's session will be like theory, tomorrow's session will be definitely good because you can see the magic how you can extract good images from a light polluted sky. Yeah, deep sky stacker is it's only for stacking, and astropixel processor is also paid software, which is meant only for stacking and gradient removal. And most of you would have know about the Photoshop and the Lightroom, so there's no need of any explanation in this. We have come end of our session. I'll show few images of mine, and I'll tell about their story. And this all these images were shot around like 1 or 2 years ago. And this is the image of the row of UP cloud complex, which is a part of our Milky Way galaxy. This is shot with a 50 lens from my home terrace. We are going to process this image tomorrow to show that how a light polluted image from a bottle sound sky can will get this good image. Yeah, right. This is an around stack of 900 images, which took like 16 hours for my laptop to stack. Yeah, so you need a decent computer to do the processing. And this is another image of Andromeda galaxy and M33, which is a neighboring galaxy to Andromeda galaxy, which is also the same around 1 hour exposure from a bottle 3 sky, and it's a mixture of data from 3 nights. I did not mention it about earlier. You can shoot multiple nights and integrate the data as long as you can. The only thing is you need to be aware of moonlight, weather. You won't be getting that good skies in India, to be frank. So this was shot for around 3 days randomly. Okay. and this is the Omega Century cluster. This was shot way back in 2020. Yeah, this is shot with a 70 to 300 mm lens. This target is pretty bright, that with an aperture of f6.3, which is very low in terms of aperture. I got this decent image of this target, which shows that the stacking helps a lot in imaging. You need to be shooting more images. As how many images you increase, the better images output. The simple key point of this session. And this is the Carina Nebula, and this is one of my favorite image because Carina Nebula is a target where which is not that visible in our northern hemisphere, and this is widely available. I mean, we can see it easily in the southern hemisphere, but not in the northern hemisphere because due to its altitude, it's very low in the sky. It will stay for around like few hours. So this was shot in a like a very less light polluted like bottom three sky, which shows a good output of the image. I guess we are done with the session. I'm open for your questions. Yeah, Rajesh. I'll definitely share the links in the WhatsApp group. There are few books written by, I'll share them, written by RBA, who is a legend, Roger Berner Andrea. He's a legend and pioneer in astrophotography. I'll share all the books, YouTube tutorials, which will definitely help you in your images. Yeah. Any questions? You can ask
I
me.
saw the images you captured; those were awesome. My question is: are there any particular list of deep sky objects which can be captured untracked, or we can capture any objects in night sky?
It's a nice question. You can't shoot a very dim object like you need a good sky like bottle on class sky. Then you can try attempting an dim object which is around magnitude of 4 to 5. Sorry, magnitude more than above 8. Most of the objects which I shot is around like 4 to 6 in magnitude, so it's very easy to shoot. So it's not recommended to shoot very dim objects in a light polluted sky. You won't get any good result. You will be just wasting your camera setup on this.
Yeah, thank you.
I'm open for your question, guys. Am I audible? Yeah, it's very. Actually, I forgot to mention while discussing this. With the quick lens, it's similar to how you manual focus in daytime. Just if you want a video presentation, I will do it tomorrow. Uh, to discuss now, basically you need to focus, turn on your live view, and keep your frame on some kind of constellation or stars. Make sure if you shoot and bright target like bright star, you choose Jupiter in the sky, zoom on it using the magnifier in your camera, and focus it precisely, and make sure that the star is very small. That's how you know if you're in focus or not. Most of the time, beginners will definitely fail in focusing. I have done that a lot. So you need to be very, the stars need to be very pinpoint while shooting. Yeah. Is that fine, Kiran? Yeah, as I said, kit lens are for only for a beginner who starts their journey. Investing in a prime lens is very important for getting a decent image. So because of its optical quality, kit lens is for just starting. You can do some wide scapes like Milky Way. If you invest in a prime lens, your total history of photography will definitely change. So it's a good decision to get a prime lens than to struggle with a kit lens. Yeah, it won't be that sharp in very low apertures. Okay, any more questions? Yeah, I'll take. So let's say it depends on the focal length you are shooting. If I'm shooting at focal length around like let's say 20 millimeters of magnification, there won't be much movement in the sky. I can easily shoot around 50 shots before reframing. Okay, and while shooting, the something you need to note is that between each individual shot, there need to be the interval of 1 or 2 seconds for the camera to write the data from our sensor. You are not supposed to shoot frames in a continuous row unless you have a good memory card and high-end camera. Otherwise, there will be issues in your SD cards. And to reframe, let's say reframing is more important if you start shooting at higher focal lengths like 50 mm, 300 mm, 85. So for 50 the recommended value is from my side is that around after 20 shots to 30 shots you can easily reframe. To reframe, just make sure keep your target. Let's say I'm shooting the Orion Nebula. I'll keep it in the center while starting off the session and let it go for the 30 shots. There will be a movement. Then turn on your live view and bring it to the center as possible and start shooting again. That's the way you can easily reframe and do that. And there will be lot of stacking errors if you are just starting now while reframing, because that's how I did. My images were most of them were a failure in the beginning. Yeah, so it's not that easy in the beginning, but you can definitely master it. I hope I answered your question. Yeah. And use your yeah, it's a nice question. Yeah, you can use in a basic computer like mine is an 8 GB RAM and i3 which is like 10 years old. I did most of the them. Even this live session is from that. So it's very much possible. Like you need to note that it will take a lot of time for stacking. As I said, for the stacking of 900 images, it took around like 16 hours, like almost the entire day to stack. But if you are very much free, as I said, I started in lockdown. I had nothing to do, so you can do that. So there's no definitely need of an high performance laptop or PC. But if you have them, your work will be very efficient. But you can do in any type of computers with a decent 4 GB or 8 GB of RAM is more than enough. And try to use an SSD if possible, which will definitely help in your process. I'll be sharing the PPT or the presentation in the WhatsApp group. Go through it, and if you have any doubt, please feel free to let me know. I'll definitely answer your questions and queries. Any more questions? And for a question, Have you guys anybody have shot? I know a few of my friends in this session have already shot, but other than them, have you ever tried and failed like that? If you have any story, kindly share that. It would be very nice. I hope most of you have at least tried them at least once. Most of them, I guess. You can turn on your mic and speak, or I can drop your messages in the chat box. Anything is fine. Hello. Session complete பண்ணிடலாம். ஓகே. நீங்க இல்லையா இதுல மீட்ல? Yeah, you can definitely try the 50 minutes. It will definitely change the way you shoot. I can guarantee that. But you need to be shooting for at least few years to get a decent image. Yeah. If you have any queries, please get in touch with me. I have good experience in shooting 15 minutes. I have tried shooting the Milky Way with yeah, it's nice. Like I have the same lens 18 to 140 kit lens, but I didn't get much chance of shooting the Milky Way in wide angle due to the light pollution of sky and without any foreground. It didn't make any sense for me to shoot the Milky Way in wide angle. So I directly jumped in shooting the deep space images. Yeah, it's nice that you guys have tried shooting.
Okay. Hello, Srinivas.
Yeah, yeah.
Yeah. So we have completed it, or
I didn't get you.
okay, fine then. So, some questions I have asked, and you have answered them very well. And guys, so some people are here. If you have any question, means you can directly shoot it in the group. So that group is entirely for you all guys to discuss about that. Today's I have a teacher some of the steps regarding the features and the need for astrophotography. Tomorrow, the session will be directly get into the post processing techniques and the steps and all. So, yeah, be ready for that. And some peoples are here. I'm just going to give some of the it's not a task, it's a fun task. Like, some peoples have an experience in capturing the sky, right? So, if possible, just capture the, I guess, moon. Srinivas, so after 11 p.m., we can see the moon, right?
Yeah, we can see the moon.
Yeah, it will
They have
rise lately,
have
I guess.
if they have clear sky, they can shoot the Milky Way right now. Uh, they can go outside and shoot.
Right now,
Yeah,
it already have risen.
yeah, it's rising. You can definitely shoot in at least in an
Okay.
hour, right?
I guess it may be in a horizon, I guess.
Yeah, we can shoot. We can keep the test the
Um,
challenge.
and when will the Jupiter conjugation with the
I'm
moon?
not sure about Jupiter, but the Saturn is this month, the 20th of August. We'll have this opposition. Yeah, I think
Okay,
this Moon and Jupiter conjunction is around August 8th, I guess. If I'm not,
August 8th.
yeah, I'm not
Okay,
sure.
fine. Then we will give some fun tasks for them to capture the things and can share the photography with our group members.
Definitely.
Okay, guys. If possible, just try to capture the moon today. And after that, the post processing technique will be taken by Sai. So after that, you can enhance your photography as well. So thank you for everyone to stay up till now. And I guess you have learned some things. Some of them may didn't get what exactly Sai said. But after that, we will post the PPT in the group as well. So for your reference, you can use it. Okay. So, guys, we will wind up this session and just make the group an active because this is not a college group where we are posting some of the technical stuff. This is entirely for you all. So, just interact with us in the group. Okay. Okay, guys. Thank you. And thank you, Sai Srinivas, for this wonderful webinar. And you have done your best today. And tomorrow, we are all waiting for you.
Yeah, and
Okay, guys.
I have
Mm.
something to tell. I'll be sharing the software links, and if you want to follow along with me, you can definitely. You're supposed to download the softwares in your laptop or PC, so that it will be very interactive tomorrow. Yeah, I'll be sharing the link
Yeah,
and how to download.
definitely. So you can put the entire steps in the group, Srinivas, because a lot of people are left already. So
Yeah,
we
yeah,
can interact with them in the group.
yeah. I'll do.
Okay, guys, bye. I will wind up the session. Thank you, and be ready tomorrow at sharply at 6 p.m. See you there. Bye. Take care.
Yes.